Namaste, dear Krishna. I, JVWU Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU Women's University and the Faculty of Education and Methodology. So today's your session, the basic topic which will I discuss in this your session is the transmission impairment. Just recall one thing that just previous this session I have discussed the transmission media, in which we have discussed about their basic elements, what is the transmission media, what is the importance of transmission media, isn't it? And there are two types, we are using the wired and wireless transmission media, and there are various guided and unguided media we are also using that things. And there is one more terminology we have discussed in that once, that the basic elements during the transmission, constructing the transmission media is the transmission impairments. And now I have just discussed these topics in this session with deep knowledge regarding the transmission impairments. Clear? So to make it in easy way to all of you, that's I'm just going to share the some files in which this topic is mentioned in brief form. Okay, so hold 1 minute. Yes, this one is the transmission impairments. Now, transmission impairments is what? What is the transmission impairments? When the received signal is not identical, I have just mentioned this lines in the previous session in the transmission impairment, that when the signal, suppose sender has sent some signals to the receiver side, but receiver has received that signal but they haven't identified, and you can say that that signal is not identical, that from where which source that signal has comes towards the receiver side. So this is known as the this is happening just due to the transmission impairments. Clear? The quality of signal will get destroyed and lost due to the transmission impairments. So what will be the causes of the transmission impairment? Transmission impairment, the at- atten- the attenuation, distortion, noise, isn't it? So transmission impairment has three factors, or you can say the on which it will affect your the attenuation. Attenuation means the loss of energy. Attenuation means the loss of energy, and here we have also discussed that destroy the quality of the signals. It means what? In the signal, the energy of that signal whatever has, they goes to be degraded and this goes to be lost, isn't it? So that means that the energy, loss of energy, the strength of signal decreases with increase the distance, which cause of the loss of energy, and it means loss of energy. Okay, the strength of signal decrease and increase the distance causes the loss of the energy in overcoming the resistance of the medium. If the medium resistance is going to be increased and the distance is going to increase, then the loss of energy must happen in that cases. So this is also known as the attenuated signals. Amplifier are used to amplify the attenuated signal, which gives the original signals and back and compensate for this loss. They are just going to be back and also to compensate these forms. Here you can see that this is the original form of the signals, and here the signals goes to be attenuated. It means due to the distancing of receiver sides, the loss of energy is going to be happen here. So this is the attenuated signals, and the amplifier again try to recover that signal. So here you can see that the amplified signals at last. Okay. And you can see here the point to point, isn't it? Point transmission media. Through the transmission media we have transmitted the signals or the data, which is converted into the signal form. Now whenever they have reached to the point 2, due to the large distance, this goes to be attenuated, and then we use the amplifier, which generates the amplified signals, which is similar as to the original signal volume. Clear? So attenuation is measured in the decibels, and it measures the relative strength of two signals or one signal at two different points. Now attenuation, which is measured in the dB, equals to 10 log 10 P2 by P1.2 by P.1. Okay, this is the formula to find out the attenuations. Okay, so point 2 by point 1. So P1 is the power, P1 is the power at sending in, and the P2 is the P1 is the power which is at the sending in, and the P2 is the power which is at the receiving end. This is well known. Now, somewhere the decibel is also defined in terms of the voltage instead of the power. In this case, we can also say like that, because of power is proportional to the square of the voltage. The formula is here will be now attenuation, which is measured in the decibel, equals to 20 log voltage 2 by voltage 1. This voltage 2 is by the P2, and this voltage 1 is by of the P1. Okay, so B1 is the voltage at sending side, and B2 is the voltage at the receiving end. Now this is basic all about the attenuation. Now if we discuss about the distortion, then what will happen? Distortion occurs when there is a change in the shape of signals. When the shape of the signals going to be changed, this type of distortion is examined from the different signals having different frequencies, and each frequency component has its own propagation speed, so they can reach at a different time, which leads to the delay of the distortions. Now you can see in this example here, the diagram which is shown in this word files, is that here is the composite signal sent, which is at the receiver side, and whenever this signal is transmitted and transformed into the other signals form at the receiver side, this is formations of this type, isn't it? So here this signal is formed, and this is also, and this is the composite in the phases. Clear? Now this is the part of your sender, and this is the part of your receiver. This is not the part of the receiver, this is the part of sender, and this is the part of the receiver. It means what? This composite signal is sent, and the composite signal is the combination of these three signals. Clear? So now when the composite signal reached at the receiver side, okay, so now the whatever the signals, this is distributed into the their original signal, through which we have combined and makes the composite signal, and then this is received at the receiver side, that is different to the same composite signals. Clear? So it means what? There may be some noise occur in this signal. Which signal? Composite out of the phases. There is some noise occurs in that signal. So the receiver side signal is not matched to the sender side signal. Clear? Now, if we talk about the noise, what is the noise? When data is traveled over a transmission media, some unwanted signal is added, which creates a noise, and which creates some distortions in the original format of the signals, and that is known as the noise. Induced noise comes from the source, as motors and the appliances, whatever you are using in that things. The device act as sending antenna, and transmission media act as a receiving antenna. Thermal noise is movement of the electrons in wire, which creates an extra signal. Crosstalk noise is when one wire affects the another wire. Impulse noise is signals which high energy that comes from the lightning or power lines. Clear? So you think that what is these all the things? Isn't it? This all are the types of the noise. Suppose induced noise. What is the induced noise? This noise comes from the source such as the motors or the appliances, whatever you are using at the source side, and the distance, the device act as sending antenna and transmission media act as the receiving antenna. And the thermal noise, suppose thermal, what is thermal noise? Thermal noise is the movement of electrons in which creates an extra signal, which creates the extra signal, that is called the noise, which is the additional signals or the extra signal, that is obvious the noise, isn't it? Now if you talk about the crosstalk noise, then when one wire affects the another wire, then crosstalk noise will occurs. And impulse noise is signals which high energy that comes from the lightning or the power lines. And you can see here that there is point 1 and point 2. This is connected with the transmission media, and here this signal is transmitted over this transmission media. And you can see whenever these signals is reached to the middle of the transmission medium, then there might be some there might be some unwanted noise will be added in this due to the distortions in the channel. So here you can see that this is the noise which added this transmitted signal. And whenever the signal is received by the receivers, that name is point 2, then that signal is totally different to the transmitted signals which is sent by the senders. Clear? So this is basically all about your transmission impairments. Now I will also recall these things once again. So please listen this carefully. So I am also recalling this once again, the transmission impairment. Like in the data communication system, you can also say that like analog and digital signals go through the transmission medium, and transmission medium are not ideal. So there are some imperfections in the transmission medium. So the signals sent through the transmission medium are also not perfect, and this is called the signal impairments. Clear? So there might be some consequences of this transmission impairments also. Like first you can say that like what for the digital signal they may occur bit errors. Digital signal they may occur bit errors. Why? Because the in the digital format of the signals, they contains only the binary value, either one or the zero. So the bit error may occurs in that cases. Okay, for analog signals, these impairments degrade the quality of the signals. Clear? Now the causes of the impairments is just only I have told you that the factors of the impairments, isn't it? Not the types. That is the factor of the impairments, like what? Attenuations, distortions, and the noise. Through which factors the signal impairment or transmission impairment generated. Clear? So that is the causes of the impairments. Now the attenuations, I am going to again repeat this once. Attenuations means the loss of energy. That is weaker signal. Whenever signal transmitted through the medium, it loses its energy, and so that it can overcome by the resistance of the medium. Clear? So that is why a wire carrying electrical signal get warms, and if not hot, after a while some of the electrical energy is converted to heat in the signal form. Isn't it? Amplifier are used to amplify the signal to compensate for this loss. And if we talk about this figure shows the which I have shown you this the figure basically. So the first figure, effects of the attenuation and the amplification, in which original signal is transmitted, sent, and the attenuations are created in that signals in the middle points, and then the amplifier used to amplify that signals. Clear? So a signal has lost or gained its strength. For this purpose, engineers use the concept of the decibel. which is I have used the formula of the decibel. So concept of the decibel is used by this energy engineers just due to the loss in the signals. So decibel is used to measure the relative strength of two signals or signal at two different points. Clear? If your signal is attenuated, then decibel is negative, and if signal is amplified, then decibel is positive. So attenuation decibel equals to 10 log 10 P2 upon by P1. Clear? So where P2 and P1 are the power of the signals at point 1 and point 2. If you talk about the distortions, then I have already told you that if when then you see that there might be some changes in the signal shape, then this is called the distortions. It means there must be noise occur in that signals, and they changes the meaning of that signals after the receiving side. Clear? So, and if you talk about the noise, so noise is the third point. Noise is another problems. There are some random and unwanted signal mix up with the original signal is called the noise. Noise can corrupt the signals in many ways along with the distortion introduced by the transmission media. So this will be the diagram will same as the your uh, previous the diagram which is in the distortions, that you are sending the composite signals, and then composite signal are converted into the multiphases, and these multiphases component signals are sent to the receiver side, and then we have received the again composite signal which is totally different through the by the sender side signal, isn't it? So different types of the noise will be here, like thermal noise, intermodulation noise, crosstalk, and impulse noise. Thermal noise is basically is random motion of electrons in conductor that creates an extra signal not originally sent by the transmitter. If you talk about the intermodulation noise, so more than one signal share a single transmission channel. Intermodulation noise is generated through this one. Crosstalk is basically an effect a wire on another wire, and impulse noises like the impulse noises irregulation pulses or spikes which is happened and generated by the phenomena like the that comes by the power line, clear, and lightning and spark due to the loose contact in the electric circuits and so on. So this is all about your transmission impairments. If you students have any problem regarding this session, then please put your query into the comment section box, through which I will recover that your comments or your questions or query in the next session with you. Okay, and please read the all the possibility questions which may arise through these sessions. Also clear that ones by yourself, like the what is the transmission impairments, what is the importance of how it distortion affects the transmission impairments, what is the role of noise in the transmission impairment, what are the various types of the noise, please explain that, isn't it? Then you have to write the concise point of all the questions, clear? Okay, and please also refer this topics from the various standard books, and also use the various online websites through which you can get the valuable or informative data. Okay, thank you.